Describing functional relationships from graphs. Lesson 16, notes review. Again, this is just the notes review. You should have gone on to Schoology and uploaded to Notability just the notes review, not the full set of notes. If you take a look at this, see how it's spaced out a little bit more? If this were the actual notes, it'd be kind of condensed a little more, crammed, and there'd be parts at the bottom of the page here. But this is just the notes review, so take a second to check to make sure you uploaded just the notes review. After you finish this, then you can go and upload the full set of notes to be filled out at a later time. Okay, so you should recognize this problem, this type of problem. We did something like this in the notes, and then also at the last worksheet, worksheet 15, there was a problem just like this. Patrick is hiking down into a canyon. The table shows his elevation above the canyon floor at different hours during the course of the hike. So he starts at the top of the canyon and he's hiking down. So if you can picture this, he's descending. And if he's descending, that means we would have a negative slope. For question number 1, they want us to write a linear function that models this situation. Remember, in order to write a linear function, they want us to write an equation. And the equation's going to be of the form y equals mx plus b. This is slope-intercept form, where m represents the slope and b is the y-intercept. Well, in this case, we're calling slope our rate of change and our y-intercept the initial value. He is hiking down, Patrick is hiking down at a constant rate, so it's a linear function. So I could pick any ordered pairs here that I wanted. I could have picked these two, these two, these two, and these two. I just picked the top two, just to pick the top two. Normally I pick the smaller numbers. They're on the left side, they're the smaller numbers, the right side they're not, so it doesn't really matter. I just picked the top two. Okay, so we're going to start by subtracting from the bottom up. Start by subtracting from the bottom up. So we're going to take the 2,812.5 minus 3,750. If you do that, you should get negative 937.5. On the other side, 2.5 minus 1 is 1.5. Now remember, your slope, your rate of change, is the difference in y value over the difference in x values. Difference in y values over the difference in x values. So the negative 937.5 would be in the numerator, and the 1.5 in the denominator. Okay, go ahead and divide those out. You should have gotten negative 625, and it's going to be feet per hour. How did I know it was feet per hour? All I have to do is look at my chart. Right there's the feet, right there's the hour. So, and it makes sense that it's negative because they're descending. He is descending down into the canyon. Now we need to find the y-intercept, the initial value. So let's start by writing this first. Remember, the initial value, your y-intercept, is the value of y when x is 1 minus the slope. The value of y when x is 1 minus the slope. All right, here, I've got my x is 1, and I see to the right of it the value of y. So the 3,750 is the value of y when x is 1. So this is the value of y when x is 1. So I'm going to take that 3,750 and subtract our slope. Now be careful, this is not correct. It's not 3,750 minus 625, it's minus negative 625. So you have to make sure you're putting parentheses and putting negative 625, and that makes a huge difference. Because in the end, minus a negative means we're going to end up adding, and when you add those two numbers together, you should get 4,375 feet. Okay, so now take this information, take your negative 625 for your slope, take your 4,375 for your y-intercept, and I would want you to write your equation. So your equation is of the form y equals mx plus b. Put your m in the first highlighted part and your b in the second highlighted part. So go ahead and write your equation. Okay, I'm not going to help you with 2 and 3. For 2 and 3, you've got two options. You can look at your using functions to model relationships 15 notes. So in other words, go to your lesson 15 notes, look at example 6. If you look at example 6 in the notes, this is like example 6b, and this one is like example 6c. So go to your notes, and that's how you would find your answers to 2 and 3. For question number 4, at what time will Patrick reach the bottom of the canyon? To figure that out, you're going to have to use this equation that we found up here. So take that equation that I just circled and rewrite it down here. Now, if Patrick reaches the bottom of the canyon, what would his elevation be? Remember, he's hiking down, so he starts at 4,375, and each hour that decreases by 625 feet. Eventually, he's going to reach the bottom of the canyon, and when he reaches the bottom of the canyon, that means his elevation will be 0. So when Patrick reaches the bottom of the canyon, his elevation, in other words, y, will equal 0. So what you're going to want to do is take this equation that you solved for in number 1, and you're going to plug in 0 for y. And you're going to end up solving for x. So you plug 0 in for y, and this now becomes a 2-step equation. You would box your x term, take your constant to the other side, and solve for x. So you could pause the video, go ahead and do that, and in the end, you could write your answer. Patrick will reach the bottom of the canyon in blank hours. So when you're done, please make sure your answer is in word form. So that's all the help I'm going to give you on the notes review. When you are finished, just double check your answers. Make sure you're using the notes example 6, or you could use the worksheet 14 through questions 14 through 17. So worksheet 15, questions 14 through 17. But I would suggest using lesson 15 notes example 6 to help you complete this problem. If you have any questions, let me know.